Okay, I'm back. Now it's time to solder in the new socket. And the socket I'll be using is a very high quality. It's what is called a dual wipe contact IC socket. These are very high quality. I do not use machine sockets, not for ICs. These are the best sockets for integrated circuits. And I believe they're called dual wipe contact IC sockets. These are very high quality. And I got the same thing for the kickstart ROM as well, because I'll be doing that next. But before I put in this socket and solder it in, I want to talk about what's going on here. So let me zoom into here. Okay. And let me get my pointer. Okay. Alrighty. Okay. Usually when an Amiga 2000 has suffered damage from battery acid, one of the problems that can occur is that these one or two traces down here can be broken. And they're very fine traces, very small traces, so it's hard to see if they've been broken or not. So if you ever solder in the 68000 microprocessor socket, okay, but it still doesn't work, take your multimeter and set it for continuity, or get some kind of a continuity checker, and make sure that these traces here goes to the pins where they need to go. Like right here, these two holes here are suspect to not making really good contact with those two traces. So after I solder in that socket and I plug in the processor, if it still does not work, what I'm going to have to do is use patch wire to connect those two pins on the processor to where they need to go, you know, around the board here. And the type of wire that I use, okay, the type of wire that I use, I'll show you what it is. I'll zoom out a little bit. Well, zoom out. Okay. It's this kind of wire here. This is patch wire. It's a really fine wire. It's solid copper, and it has like a coating on it that can be burned away with your soldering iron. But this is what we use in the electronics industry if we have to make corrections to a board. In fact, when I was an engineer's assistant, part of my job was the engineers would leave prototype boards or the boards that they're working on my desk with instructions on what needed to be the modifications that needed to be done to the board. And a lot of times I would use this kind of wire here to do the modifications. This is the type of wire. In fact, this is exactly the type of wire that I used right here, this blue stuff here. This is what I used to use, you know. But yeah, I used to have to repair and rework a lot of engineering screw-ups, you know. That was one of my many jobs in my 25 years, you know. But yeah, this is the stuff that we use right here. So yeah, so the next thing we got to do is we got to solder in the, I'm going to zoom in again. As you can see me put in the processor socket. Okay. And let's see. Pin 1 of this, let's see. Pin 1 is going to be, I believe, right here. Right here, I think that's pin 1 right there. So we'll just go ahead and put this. I need my goggles for this. Yeah, I'm planning on recapping this board too. But yeah, I think that's going to work out good, and that's ready to be soldered in. You know, that's a really high quality socket. I'm just hoping that I don't have to do any patch wiring. But I probably will have to do patch wiring to connect these two pins here to where they need to go on the board. Probably going to have to wind up doing that, because I don't think there's enough plating on the inside of the through holes. I think that was just totally eaten away by the battery acid, and that's a shame. Sometimes that happens, but that was the reason why. I mean, you could see all this corrosion here, all this oxidation, corrosion, whatever, and that's what made removing the original socket so difficult, because when there's corrosion, corrosion does not allow the transfer of heat. It's a very good conductor. Insulation or insulator of heat. It doesn't allow very good transfer of heat. Okay, or it doesn't allow you to solder either. That stuff has to be cleaned off before you can solder. You know. But I think it'll solder just fine. What I got here, I don't know, let me see. Let me look at it with my magnifying goggles. Now, Gadget UK 164, I was watching some of his videos. I mean, he was doing the same thing on his Amiga 2000. And he used a fiberglass pen to clean up some of these. I don't have one of those, but I think it'll still solder in just fine. You know, I'm only concerned about these two holes here. That's what I'm concerned about. Those two right there. The rest of them, I think they should be okay. You know, I think they'll be okay. Yeah, I think they'll be okay. So, let's turn on the old iron, shall we? Well, let me put the socket back in it. Put the socket back in. Yeah. Okay. Alright. So, I will be back shortly, and we will get this new processor socket soldered in. Okay, let's get this socket soldered in. I usually use a little bit of masking tape here to hold the part in place. Until I can get it tacked in. Just like that's fine. And masking tape does not generate static electricity because it's paper tape. It's made out of paper. Do not use cellophane tape, because that generates static electricity. So yeah, you don't want to use cellophane tape. And just enough to hold it in place until I can tack it. You know, so I can tack it down. And you just tack, like, I think the opposite corners, you know, just tack the opposite corners. And I'll take the tape off and I'll double check it. Let me go ahead and... Okay. Where's the processor socket? Right, let's see, it's right here. Alrighty. Let's tack this baby on, shall we? So that's tacked on that corner. Tacked on that corner. Alrighty. And I'll zoom in so you can see what I did. It's right there, I think. Put it right about. And zoom in. Yeah. I tacked it in right there, and I believe right there. That's where it's tacked in. And yeah. Is this bend or something? Okay, anyway. Okay, and then we'll pull the masking tape off. Okay. And then we're going to double check it and make sure that it's actually in there really good. Can you see it? Make sure it's tacked in, I mean it's in there really good. Okay, so that's in there. Okay. Yeah, you want to make sure that the socket is well seated on the PCB. Because if it is not, when you go, I mean when you press the 68000 microprocessor in there, it can actually damage the socket if it's not, you know, seated properly. If the socket's not seated properly. So, yeah. Alrighty, so now I'm going to go ahead and solder that socket. And hopefully you'll be able to see me solder it in place. It's right there, right? Yeah, I just want to make sure it's lined up so you can see it. And let's get this done. Okay, I'm using the high quality Kester solder. This is really good quality solder. Alright, so we're going to start over here. Yeah, when I'm done here, this computer should boot up. It should boot up. So I saved another Amiga computer from the landfill. Rotten shame when one of these have to go to the landfill. It's not too good. I'll show you how to properly clean the board after you finish soldering. No, you don't spray alcohol on the board and then use a toothbrush and scrub it. No, that's not how you do it. I will teach you the correct way to do it. Okay. Yeah, I will teach you the correct way to clean the board after you finish soldering. Yeah, because of the corrosion in these holes, it's very hard to manage the flow of the solder. But with my experience, I know how to handle stuff like this, so I can compensate for it. I might have to put a drop of liquid flux on some of these to get the solder to flow in properly, because I do have liquid flux. I usually use it for surface mount, but sometimes I have to use it for through hole as well. That's why it's taking me a little bit longer than normally to solder this, because I'm trying to compensate for the battery acid corrosion on the through holes. Because normally I can, if this was like a new circuit board or whatever, I can have that 64-pin socket soldered in within, hell, 10-15 seconds. I have the whole thing soldered. But because I have to use 7-power magnifying goggles and actually watch the flow of the solder going into the holes, make sure that's flowing into the holes, that takes longer. Yeah, that takes longer. Okay, so I'm going to go ahead and turn off my iron, and we're going to go ahead and clean the circuit board. And I'll show you how to do that. Let me roll up my solder. Now, whenever you finish soldering, you finish for the day resoldering, you want to make sure you wash your hands, because lead is poisonous to the human body. So you want to make sure to wash your hands when you're done soldering. Yep, when you're done soldering, make sure to wash your hands. Very important to make sure you do that. Okay, so I got my iron turned off. Let me make sure I clean the tip. I already tinned it, so it should be fine. Should be fine. Yeah, should be fine. Okay. So let me show you what I did. And then we're going to clean the board. I think it's right there. I'm just making sure, yeah. And then I'm going to zoom in. And there you go. There's the new processor socket soldered on. Right there. Okay. All right. So I will be back shortly, and I'm going to show you how to properly clean a board after you finish soldering. Okay. You're going to need some alcohol. Well, let me zoom out. I'm zoomed in a little bit too much. Yeah. In fact, zoom all the way out. Okay. Yeah, you're going to need some alcohol. Okay, you're going to need that. And you're going to need one of these types of brushes. Okay, you can get these like at your Ace hardware stores. You can get these from a lot of automotive stores, automotive parts stores. They sell these. The bristles are usually a little bit longer, and you have to cut them down to how short you want them, how stiff you want the bristles. The shorter you make them, the stiffer they are. So yeah, you need that. And you'll need what is called, these are called Chem wipes, but they're by different manufacturers. This one is Adept wipes, but the original version of these, the type that I used to use all the time in the electronics industry, they're called Chem wipes. And it's like a fiberglass impregnated tissue paper. And this is what we use for properly cleaning PCBs. Okay, and I'll show you how we do that. So what we do is we usually fold it. We like to have it doubled, you know, like that. Okay, and then we put some of the alcohol here just to wet that, get that flux wetted with the alcohol. Okay, just like that. And then we put this, the Chem wipe, right on top like that. And what this does, it sucks up the flux into this paper. And that's how we professionally do it, boys and girls, in the electronics industry. And you keep doing this until there's no more yellow on the tissue paper. Because when you pull this up, well, this doesn't really have that much of a yellow tint to it. But that's how you do it. And it'll suck up all that flux from those parts. I usually like to do it again. Like, you know. But no, you don't spray alcohol on the board and use a toothbrush. No, that's not how you do it. This is how we do it professionally. Okay? This is how we do it professionally. And you just dab it with your brush just to get it. You want this Chem wipe to soak up not only the alcohol, but what the alcohol has dissolved. In this case, it's the flux. So, yeah. That's how we professionally do it in the electronics industry. And as you can see, it does a really good job. It really cleans that up good. I'll do it one more time. Usually no more than 3 times. You don't really need to do it any more than that. Yeah, you usually don't need to do it any more than that. 3 times, that's it. Okay, pull it up, throw that in the garbage, let that air dry, and I'll show you the difference. We'll compare the two sides. Okay, so we're going to zoom in. Okay, and you'll be able to see. I'm putting my finger where it needs to be. Okay, yeah. You'll be able to see the difference between the two sides. See the difference? This is the before, and that's the after. And you can see that this side's a lot cleaner. And if you want to go a step further, you can use, drum roll please, a cotton makeup pad. A cotton makeup pad. And you can clean a PCB even further. Okay, make it look nice and pretty, you know. See, look at that. Does that look nice or what, man? Oh yeah, baby. And you can also use like a little cotton swab. Just do a nice job, you know. Now you want to like wring out the cotton swab. You don't want to put it on there soaking wet. Okay, and then just let it air dry. And yeah, that should look pretty good. Okay, we're going to go ahead and do the other side. I just want to zoom in so you can see the comparison. Okay. So, yeah. So we'll get a new Kim wipe and fold it in half. Fold that baby in half, okay. Put a little bit of this alcohol right here. Okay, just help dissolve, you know, pre-dissolve that flux. See? Just pre-dissolve that flux. There you go. Put this Kim wipe on here. Okay. And there you go. Neighbors must be home because the dogs are yapping. So if you hear that in the video, that's what's going on. Okay, well, put a little bit more on there. Usually I have to do it about 2 or 3 times. Okay, so we'll put this on there again, like that. Okay, pull it up, and as you can see, it pulls up the flux and whatever else that the alcohol dissolved, pulls that up with the alcohol into the Kim wipe. A little bit of solder out of there, but I'm not going to worry about that. It's fine. If it's stuck on her that good, I'm not going to worry about it. Yeah, it needs the 3rd time, so we're going to go ahead and do that. Alright, put that baby on it like that. And that's it. Maybe clean it up a little bit more with the cotton makeup pad. See? Just, okay, can you see it underneath the, yeah, cotton makeup pad. Like that. Make it all nice and pretty. See? I'm loving it. Just underneath the damn. Okay, yeah, that's looking pretty good. I got a little bit of stuff right there. Ain't no problem. Okay, well, clean it up a little bit. Okay, so we're going to put the alcohol away. Put it over there. Put my brush over there. I like to put my tools away when I'm done. And then I usually take a makeup brush. Boy, I find all kinds of uses for these women's makeup stuff, huh? And there you go. Let me zoom in to show you what I did. And I'm just trying to put my finger where to, right there. That's the processor socket. Right there. Okay. Yeah, it looks pretty good. I'll zoom in a little bit more. But as you can see, that turned out pretty good. Turned out really good. Let me brush it a little bit more. Yeah, it turned out pretty good. Let me flip it over so you can see the other side, the component side. And as you can see, yeah, the new socket looks pretty good. Now, after you plug in the microprocessor and you test the motherboard and it still doesn't work, chances are that you'll need to add patch wiring to one or two of these pins right here. They're usually the culprit because they're closest to the battery right here, so the corrosion might have broken one or two of those lines, and you'll have to use that patch wire to patch that. So the only thing left to do now is to plug in a brand new Motorola 68000 microprocessor. So I'll be back shortly after I find one. Okay, I'm back. I found a genuine Motorola 68000 microprocessor. So I'm going to go ahead and plug that in. I'm making sure the leads are straight and there's nothing wrong with the leads. It appeared to be okay. Well, spoke too soon. Now, I mentioned these types of pliers before. I believe it was in part 2, actually part 3 of my electronics assembly series, where I showed you the various tools that we use in the electronics assembly, industry. And I showed these. And one of the things that these duckbill pliers are good for is for straightening out the leads on chips like that. See, you just go down there and straighten them out. See, and yeah, there you go. That's one of the things that they're really good for. And I'll look down and make sure they're all within, they're all in the same line. They're lined up, But yeah, that's one of the things those are really good for straightening out leads, IC leads. Okay, so let's go ahead and put that chip in. Okay. Make sure that pin 1, right there, that's pin 1, right here. So, man, on a brand new socket like that, oh yeah. These are very high quality sockets. Yeah, they're very high quality sockets. I do not recommend using machine sockets. I can't stress that enough. Do not use machine sockets. Okay, so let me check that, make sure that none of the pins are bent. I I can just look through. There's like a space between the underside of the chip and the top side of the socket, and I can see if any of the pins are bent. They appear to be in there really good, no problems, so yeah. Okay, that's looking pretty good. Looking pretty good. And like I said, if after you do all this and it still doesn't work, well, the chances are good that you have to do some patching. Let me zoom out just a little bit more. Okay. Chances are good that you got to do a little bit of patchwork on these two pins here. They're not connected to the traces, and so you got to use your multimeter, set it for continuity, and make sure. You can also use your schematics, some Amiga 2000 schematics that will show you where these pins are supposed to go, where they're supposed to connect to on the board. And so, and if it doesn't show any continuity in a certain area, then that's where you put your patch wire. You know, and it should work just fine then after that. But yeah. So that's it for part 2. I'm sorry it took so long. Now in part 3, I'm going to remove this kickstart ROM right here and throw it in the garbage because the legs are corroded. I'll throw that in the garbage. And I'll unsolder the socket. This socket will be actually pretty easy to remove. It's not as much of a pain in the ass as a 68000 microprocessor socket. But in part 3, I'll remove the chip, I'll remove the kickstart ROM socket, and I'll solder in a brand new socket, and I'll plug in a brand new kickstart ROM. So stay tuned for part 3 of this series. My name is Hans George Campbell. And until next time.